Okay, so make sure you print out your new packet of notes. I have them posted on the home page of Canvas under Wednesday 4/8. So that will get us through the next week of notes. So the next section we're going to learn, we did addition and subtraction. If you recall in the last section, this next section is multiplication. And as you can guess, the one after this is going to be division. Multiplication of radicals is really fun, really easy. I think you guys will like it. Division's a little tricky, but multiplication's pretty easy. So let's talk about the multiplication property of radicals. What this property says is that you can take a radical and break it into two separate pieces. It's actually a double. It goes both ways. So I could say square root 6 times square root 5 equals square root 30. Or I could take square root 20, let's say, and break it into square root 4 times square root 5. So that's what the double arrows mean. You can go both ways. If you see the same index, they can be multiplied. That's all that needs to be the same, is the same index. What's underneath does not need to be the same, but the index does. Because recall in addition, in our last lesson, what was under the radical had to be the same and the index had to be the same. But for multiplication, same index allows you to multiply, or you can break it apart into separate radicals. So we can go both ways. So some of our multiplication in this section is going to be distributive property. Some of it is just going to be multiplying two factors, and some is going to be foiling. So here's a couple examples just to get you acquainted with the process. So this is one term times one term. When we're multiplying radicals, the outer number gets multiplied by the outer number. So that's 6. And then we have the number under the radical gets multiplied by the number under the radical. So 7 times 14. So only outer numbers can be multiplied by other outer numbers, and radicals can only be multiplied by another radical with the same index. And we know 14 is 7 and 2. So I just expanded it right there. So there's the first 7. This 14 turned into 7 and 2. But we've learned throughout this chapter that when we're breaking down radicals, when it's a square root, we're looking for pairs. So you can see right there we have a pair. So that 6 out front gets multiplied by anything that comes out. Because there's no symbol there, that means there's an imaginary multiplication. So this is going to come out as a 7. So this turns into 6 times 7, and then the 2 is left under the radical 2, which turns into 42 radical 2. So we're still breaking down radicals just like before. Now we might have numbers out in front, and we'll have to multiply those like we did here. Then if we have two terms by two terms, we have to use FOIL. So from first, we get 3 radical 5 times 7 radical 2. That would be 21 radical 10. So outer times outer, inner times inner. So 21 radical 10. From O of FOIL, we get negative 15 radical 5. There's nothing to multiply that radical 5 by, so it just stays the same. So the outer number is negative 15, and then the radical 5. From the I of FOIL, inner, we get positive 28 radical 2. And from the L of FOIL, the last terms, we just get negative 20. And many times the radicals can be simplified, or there might be like terms on this particular one. No, this can't be broke down. It's 2 and 5, no pairs. This can't be broke down. This can't be broke down. None of the terms are alike, so that's our final answer. So let's practice on some, shall we? So first I notice that the indices are the same, so that gives me the go-ahead to multiply. So 4 times 2 is 8. And like I said, many times after multiplying, then you have to simplify. So let's see if this one simplifies. 8 is 4 times 2, which is 2, 2, 2. 2 times 2 is the 4, and then the 2. And look at that, we have a triple. So our answer is going to be 2. Nothing's left under the radical, so we just write the whole number 2. And you should probably know, I think you should have that memorized, that the cube root of 8 is 2. That's just the work for it, which you wouldn't need to show on the test. I would hope you could go from here to here. Okay, this next one looks like a distributive property. So we have one term outside, two terms inside, no sign. So remember, that means it's multiplication. Guess I can make that a little bigger. So we're going to multiply this term by this term, and then the front term by the second term. So again, I check the indices. The indices are the same. So that means I can multiply them. So this is going to be cube root of 8 again. And then this one, you multiply the outer number. So remember, anything that doesn't have a number has a 1 there. So then that would be negative 3 cube root 4. So everybody understand where I got that? 1 times negative 3 is negative 3. And then I just tack on the cube root 4 because there's nothing to go with that. So then I have to look for simplifying. 4 is 2 and 2. There's only 2 2's, not enough to get out of jail. But this we just discovered on the last problem is 2. So we would write our final answer as 2 minus 3 cube root 4. And I have a lot of students on the test that want to make this negative 1 cube root 4. Don't do it. You can only add and subtract like terms. So the only way you would be able to subtract 2 and 3 is if 2 had a cube root 4 on it as well. But what I always think when I'm trying to decide whether I can do it is I put an X where the radical is. Can I subtract those? No, they're not like terms. So that means I can't subtract these. So this would be my answer. And there's no specific order for radicals, so I usually just leave it in the order of the problem. Okay, this next one, 2 terms by 2 terms, that's a FOIL problem. And remember, don't just FOIL and stop and circle your answer. You always have to look and see if things simplify. So from F, we get square root 2 times square root 2, which is square root of 4. From O, we get positive 5 square root 2. Remember, we can't multiply the 5 and the 2 because one's outside the radical and one's under. And then from the inner, we get negative 1 square root 2. And I would put the 1 there because we're going to be combining like terms, and it's nice to have that number there. And from L, we get negative 5. So I see a couple things that need to be done. Here's some like terms. And can't that radical simplify? What's a square root of 4? 2. Not radical 2, just 2. There's 2 2's underneath, and they come out as a single 2, so there's no radical left. And then we have 5 radical 2 minus 1 radical 2, which would be 4 radical 2 minus 5. So now we have like terms again, and that's going to give us, let's go ahead and put the answer up here since we're running out of room. 2 minus 5 will be negative 3 plus 4 radical 2. And again, I can't do anything. They're not like terms, so don't try to add those. The only way you could add them is if that had a radical 2 with it. So negative 3 plus 4 radical 2. And like I said, there's no rules for order, so I just usually keep it in the order of the problem. Okay, this next one's a little bit hefty. You ready? So this is 2 by 3, which means we can't FOIL 2 terms by 3 terms, so we have to distribute, and it's a lot of distributing. So let's start with the first term by the first term. So that would be, this is a 1, remember. So -8 radical 9. So we multiply the outer numbers, then we multiply what's under the radical. Next, we have to distribute to the second term, and that again has a 1 in front. So 1 times 1 is 1, so it'd be plus 1 radical 15. And my final answers, I never put the 1 in front, but when I know there's going to be some like terms combined later, I do that. So when I'm working the problem, I keep the 1s in front, and then for the final answer, I don't. So plus 1 radical 15. Then we need to distribute to the last term, and that would be plus 1 radical 6. So that's just the first set of distribution. Then remember from chapter 4, we also have to distribute the second number to everything inside the parentheses. So a negative times a negative is positive 8 radical 15. And if you remember from chapter 4, on the second round, we lined up our like terms to make it easier to add them later. So we got positive 8 radical 15. Then we have negative 1 radical 25. So a negative times a positive, negative 1 radical 25. It doesn't have a like term, so we'll just put it over here. And then last, so we did negative 1 radical 25. Next we have negative. A negative times a positive is negative 1 radical 10. And I see there's not a like term with it, so I'm just going to write negative radical 10 because there won't be any adding. So again, negative times a positive is negative. 1 times 1 is 1. Radical 5 times radical 2, radical 10. So now we have our like terms all lined up. So we have negative 8 radical 9. Nothing to add it to. It can be simplified though, right? So anytime we see something that can be simplified, let's underline it to remind ourselves to come back to it. Plus 9 radical 15. Does 15 have any pairs? 3 and 5. Nope, so that can't be simplified. Nothing to add this to, so just bring down the radical 6. This one can be simplified, so we'll underline it. Because we know the square root of 25 is 5, right? And then this one has nothing to add to it, so it just be negative radical 10. So we're kind of running out of room here. I guess we'll go over here because these don't take as much room. So this is going to turn into negative 8 times what? Square root of 9 is 3. So negative 8 times 3. This can't be simplified. This can't be. So just bring them over. 9 radical 15 plus radical 6. This can be simplified because the square root of 25 is 5. So we write minus 5. And 10 doesn't have any pairs, just a 2 and a 5. So we'll just bring it down as minus radical 10. So far, so good. So everybody's good with how you determine whether something can be simplified. This has pairs, 2 3s. This has pairs, 2 5s. No pairs, no pairs, no pairs. That's why they didn't change. So this turns into negative 24 plus 9 radical 15 plus rad 6 minus 5 minus rad 10. Almost done. One more.